The overall goal of this experiment is to show the preparation method of LiSES and to measure some of their physical-chemical properties in view of their application in rechargeable batteries.
This method can help answer key questions in the physical chemistry field about the preparation and physical properties of lithium solvated electron solutions.
The main advantage of this technique is that it provides an anode material in the liquid state at ambient temperature.
The implications of this technique extend toward next-generation refillable lithium batteries for electric vehicles. Current lithium-ion batteries require overnight charging, whereas refillable batteries may be recharged in 10 minutes.
Visual demonstration of this method is critical, as the steps to make the LiSES need to be repeated exactly for the best results and to avoid potential hazards.
The synthesis will be demonstrated by Andrey Lunchev, a PhD student in the group of Professor Andrew Grimsdale.
Place 4 grams of acetophenone and 100 milliliters of absolute ethanol in a triple-neck 250 milliliter round-bottom flask, equipped with a magnetic stir bar, reflux condenser, dropping funnel, gas bubbler, nitrogen inlet, and thermometer. Place the reaction mixture under a nitrogen atmosphere. Then, cool the mixture to 0 degrees Celsius. Using the dropping funnel, add 2.1 equivalents of silicon tetrachloride to the mixture in a single portion. Monitor the reaction mixture for 10 minutes, during which gaseous hydrogen chloride will form.